Okay, so we're going to do a few under our abstracts, under our abstract data structures or ADS. Right? We're going to do a few common problems that you'll find. Right, I'm going to go through them visually, of course. Right, I'm going to go through them visually and then just explain them. So the first one is, given that we have nodes, right? We have our node here in a singly linked list. We have these nodes, right? We have these nodes over here, right? The question might be, swap two adjacent nodes. So we have node X and Y. So we want to swap these two adjacent nodes without actually swapping any of the data, right? So how do we do this? So if we have some pseudocode, let's say swap, this will take in a node. Now this node that will be taken in is actually this one, the previous one, to X and Y. So it takes in the previous node, right? So in this code, what we're going to do is we're going to say, okay, X, right? X is then going to equal. I'm just using a random programming language. This isn't. I don't think this is even a valid language. Let me make it look like Python. Yeah. So we'll do the calibrations there. So we're going to say X, right? We're going to say X is equal to p dot next, and then Y is equal to x dot next, or p dot next dot next. Now, whichever one you want to do there. So we now have a reference to this guy and this guy. So how do we go about with the actual swapping, right? So when swapping, first of all, we want to make what we want to do. The first step is we want to make p points to y, right? We want to make p points to y. In that case, we're going to say p dot next is equal to y, right? Okay, so essentially in doing that, what we've done is we've cut off this connection here, cut off this connection. Okay, what do we do next? Next thing is we um want to make x point to the value after y. So what we're then going to do is say x dot next is equal to y dot next, right? So what we've done now is we've cut off this connection here. And then finally we want to make y point to x, which is different from x pointing to y. In this case, we're just going to say y dot next is equal to x. Following this, what we essentially have in the end is a list that goes like this: p pointing to y, which points to x, which points to the other element there. So p, y, x, and then whatever element was after that. And this is how you swap two adjacent elements in a single linked list without having those two lists be together, right? So this is just like a quick overview of how to do that. Now, next one is going to be for a double linked list. This one is a bit more, it's complicated and simple at the same time, because you can say it's simple because let me just show you that. So we have these nodes here, right? We have these nodes. So I want to do x, I want to swap x with y. I'm going to make this my p, I'm going to make this my t. So how do we go about this one, right? How are we going to go about with these nodes? How are we going to swap them essentially? Well, to swap these guys, first thing is, again, if we have our swap, right? Our swap, we can basically just take in x, right? We want to swap the next element after x. So you can just say p, maybe p is equal to x dot prev, because it's a doubly linked list, so we can get the previous element. Y is equal to x dot next, and then let's just say t is equal to y dot next. Okay, now what do we do here? So the first thing is first, let's approach this we approach this first of all the way we did our single linked list at first. So we do the next. So we want p to point to y, right, which is 1. Then we want x to point to t, and then finally we want y to point back to x, right? So this is simple. We're just going to say p dot next is equal to y, because we already have y there, and then x dot next is then going to equal t, and then finally y dot next is going to equal x, right? So we've essentially done that simple swapping there. Then finally, um, we then want to do the same thing but with these guys. So we want t to point to x, right? We then want y to point to p, and then we want x to point to x, the previous one. So we're going to say, okay, t dot priv is equal to x, right? And then we're going to have y dot priv pointing to p, and then x dot priv pointing to y, right? And then if I come and draw this guy now, if I come and draw it, right? If I come and draw it in the same way that we've done that one, so right, so we're going to label them properly just so we make sure that we actually haven't messed up anything. So we have our p and t, those were not the ones we were swapping. So x, the next one to x is supposed to be t, and then the previous one is supposed to be y, so you can assume x is here, and then y points to x next, right? And then points to p as its previous, so we swap them. So that's how you swap, both using a linked list, single linked list, and a double linked list. You just have to, yeah, just play around with those links. And whenever you're swapping again, remember, you are not allowed to swap actual data. What you have to swap is the nodes themselves, right? The nodes, not the data inside of them. Yeah. So the next one, I'm going to do something with stats. So in a case where you've been taught to write an algorithm, just convert this to the normal pseudocode that's, or if you're using Java, just write simple Java code to, yeah, to just do this. So I've just written it in pseudocodes because I don't know what language you'll be asked to write it in, right? But yeah, you can easily translate this to any programming language. Okay, now what's the next thing that we want to do, right? So there was one question whereby given a stack, right? If you have a stack, was it a stack or a queue? Let me just check for him. Let me just check for him. Okay, yeah. Anyway, it works both ways. So given a queue, right? Given a queue, if we have a queue with the elements, let's say 1, 2, 3, 4, how can we reverse these elements, right? We can reverse these actually using a stack. So how do we do this? Visually, it goes like this. If we have a stack like this, and then we have our queue there. So our queue will have 1, 2, 3, 4. So what do we do? First thing is we dequeue this one. We dequeue one and put it into the stack. So we have one there. Then what are we going to do next? We're going to dequeue 2, put it also in the stack. Then we're going to dequeue 3, put it in the stack. And then finally we're going to dequeue 4 and put it in the stack, right? In the end, what we have is something that looks like this. We're going to have our stack looking like 1, 2, 3, 4, and then an empty guy there. So this will be empty. And then what we then just have to do is that we just have to pop these back, right? We just have to pop these guys back, which is going to be, if we pop Because remember, from the stack things enter from this way, isn't it? So we're going to pop 4 first, right? And then enqueue it. Then we're going to then do 3. So we pop, then we enqueue, right? Enqueue meaning it will be after. And then finally next we're then going to do 2. So we pop and then enqueue, and then finally 1. In the end, what you have, if we follow that step, right, follow those steps, 4 was popped first, so it will be at the and then it was enqueued, so it will be at the very first. Then now we're going to have 3, 2, and then 1. So this is how you can reverse a queue using a stack, and I'm pretty sure you can do the same thing with a stack and a queue, like the other way around. Yeah, yeah, free to actually do that. So this is just some simple problems you might find. So swapping those and then reversing those guys.